Assalamualaikum warahmatullahi wabarakatuh. This is our research with the title Robust Optimization Model and its Solution on the Garbage Vehicle Routing Problem with Time Windows. I am Evi Liza and our team is Siska Oktarina, Ning Eliati, Fitri Maya Puspita, and Akmal. Our affiliation from Department of Mathematics, Faculty of Mathematics and Natural Science, Universitas Sriwijaya, Indonesia. Introduction. This research based on vehicle routing problem is a combinatorial optimization problem. Vehicle routing problem resected by time windows is called vehicle routing problem with time windows. In reality life, we find an uncertainty data. It is discussed on robust optimization. This research will be discussed robust vehicle routing problem with time windows. Problems that arise in waste transport vehicles that often experience delay at the location of temporary waste disposal site and must be considered. Delays occur due to the increasing number of temporary garbage dumps so that travel times are not optimal. This study aims to study the robust vehicle routing problem with time windows on the uncertainty of travel time to minimize travel time and obtain the optimal route from waste transport vehicles. Research method. The steps needed to minimize vehicle travel time are as follows. Step 1. Data description. Step 2. Defining variables and parameters. Step 3. Formulation of this model. Step 4. Solution of the model using the Lingo software. And the last step is result analysis. Result and discussion. The RVRPTW model is simulated on the waste transportation route in Ilir Barat 1 District Palembang to minimize the travel time of waste transport vehicles. This working area has 9 work areas and 2 daily working time, namely daily working time 1 and daily working time 2. Variables used in this model. Parameters used in this model. Data description shown in table 1. This working area has 9 regions. Define the set of all nodes with N and set of all vehicles with V. A set N without a set M represents of the number of temporary dumps and M represents the final dumps. The formulation of the RVRPTW model for the problem of transporting waste is given as follows. Minimize Z and some constraints. During daily work time 1, waste transport vehicles carry out waste transportation in Region 1, Region 2, Region 3, and Region 4 with a total daily work time of 13.6 minutes as shown in table 2, so that the vehicle has a waiting time of about 26.4 minutes to carry out the waste transportation process again for the daily working time 2. At 16 o'clock, the garbage transporting vehicle returns to the garbage collection process. The calculation results from the RVRPTW model for other work areas are as shown is in table 3. During daily work 2, the waste transport vehicle transports waste in Region 5, Region 6, Region 7, Region 8, and Region 9, with a total daily work time of 337.8 minutes. This shows that the garbage collection vehicle arrived later than the daily working time duration of 97.8 minutes. Conclusion: the more nodes will affect the arrival time of the vehicle at the next node. For the case of the waste transportation road in Ilir Barat 1 District Palembang, the arrival time of vehicles at temporary dump site was delayed. Even though it has 2 daily working hours per day, the total travel time of the garbage transport vehicle is delayed from the daily working time. This is not good because it can affect operational costs. The occurrence of delays in waste transport vehicles from the daily time duration can be caused by the large number of temporary disposal sites and the distance from the final disposal site, while the work area is only served by one waste transport vehicle. Thank you for your watching. Wassalamualaikum warahmatullahi wabarakatuh.